So this is the course that you enroll for. Okay, I hope you are in the right class. We are for the AT 7026, the Semantic Web Technologies. And this is me, Shutipan Anutariya. And as we know each other already, my email address for contact of class matters. Okay, and then, okay, one moment. Okay, I will give some introduction a little bit about this course, what we expect to learn, and then some of the introductory stuff about the semantic web. So about the course itself, okay, we learn about semantic web technologies as part of the title that tells us. And what does it mean by semantic web? I believe that many of us are very familiar with what we know by the web already, right? The internet, the web technologies, these are what we are very used every day. And they are kind of fundamental technology as of now for everything for the moment, okay? But the term semantic web actually has another word that is semantic, okay? The word semantic itself, I think, is the key that makes it different from traditional web. So the point is that the idea behind semantic web is actually to, one moment. Yes, the idea behind the semantic web is actually to incorporate explicit semantics into the content of the web. That means into the web data. Okay, by making use of, what does it mean by explicit semantics? Actually, the idea behind is by making use of a certain formal knowledge representation. Some of you, I guess, might already learn a class with Professor Dung under the course knowledge representation something. I think that is part of the DSAI. Pardon? It's not compulsory. Okay, okay. So anyone took that course? No? None? Oh, two. 1, 2, 3. Okay, all right. So what is the name of the course? Knowledge, representation, and reasoning. That's it. Okay, thank you. All right. So the concept of semantic web is actually bringing semantic into the web data or the web content. And what does it mean by bringing semantics? Bringing semantic is, in this context, is by incorporating formal knowledge representation and, of course, reasoning mechanisms into web data in order to make the web data having explicit meaning, okay, formal meaning, unambiguous meaning, and so on. So that is the main idea. And by allowing this to happen, it will enable several types of applications that allow web data to be integrated, web data to be manipulated by computer applications easily and accurately. Okay, and we will have a look at some of these details throughout our course. So the learning outcome. So what do we expect for this course that you and all of us will learn together? Okay. First, of course, we need to be able to understand the concept of semantic web and related technologies. In particular, the technology we will learn would include RDF, Resource Description Framework. Okay, some of the query language, namely Sparkle. These are kind of new terminologies for you, but we will learn them, as well as what we call ontology. Okay, it's kind of a knowledge representation that allow us to model certain concepts, domain, and so on formally. And then we will be able to do certain types of reasoning using the the technologies we learn, and we would be able to model, design some form of applications that employ the technologies we learn. Okay, so these would be topics we learn. Okay, as per today, I would focus on discussing this introduction to the semantic web and web of data. I would perhaps tomorrow, next session, talk about linked data and also RDF, Resource Description Framework. We will, along the course, we will discuss about certain use cases, case studies, and some applications. We will learn about the Sparkle language. It's kind of query language that allows us to query data that is in the form of web semantics already. And for sure, we need to learn some tools. We will make use of, we will learn about ontologies and model ontologies. So these are more or less the topics we will learn. In terms of evaluation, okay, the time is short. We will not have midterm exam. Okay, otherwise it's like we learn just 2 weeks and then exam. More or less, we will have some kind of learning activities, assignments, or some of the classroom stuff that we work together. Okay, projects and so on. So we will have only final exam at the end. There will be some, not a lot, because actually it's not possible because of the time. Okay, some assignments and readings, presentations. There will be mini projects that you need to do by by developing some ontology to model certain things. And of course, your participation, attendance would count, would be part of the evaluation as well. And as you know me, we will use open book as part of the method for the exam. Pardon? You can, but not open neighbor, not open to the friends or people, just you, that's fine. Google Classroom, this is the code. I think you all are already there. So this is not necessary to talk about. Okay, before we look into the detail of the content for today, anything from anyone from the online or from the in-class? Okay, if not, yes, feel free to move. Because if you're too aligned, then you cannot see me, right? Yes, you can even move here. Okay, I think we have 2 big rooms. We can actually close half of the room so that everyone are in the very first first half of the room. Okay, anyway, so let's look at a little bit about the history, the evolution. And I feel that maybe I'm too loud. Do you think so? Hello, hello. Do you think it's lower? Do I speak lower or it's the same? But when I stand there, I hear myself very loud. So am I too loud to you? The speaker? Okay, it's fine. Okay. All right. Okay, so if there is no question or comment, okay. The very first classes, I'm sorry, maybe it would be a lot of me talking, but I will try to be less talkative and let you do more of the doing, less of the talking, listening to me, okay. But let me give you some background first so that we understand the background, the context, and the importance of the thing we are going to learn in this course. First, we talk about the evolution of the web. Many of these things are things that we can just quickly go through, see the figures and text, and just grasp the facts and figures more or less, okay? As of, I think if we talk about now, it will be even bigger. So as of 21, okay, this is the number of internet users and it's increasing and increasing. So it's saying that the internet, okay, has already, I mean, the technology for the web and internet already served people over 5 billion people around the world across many of the continents. Okay, so from these statistics, it can tell us who are the majority users of the internet. And here we are, right? From Asia, the highest number of world internet users. And if we look at number of websites, okay, you can see also the trend that we have more and more of the websites available as of now. Okay, and if we look at the very first website, okay, the world's first website, this is the one. In December 1990, the website from Tim Berners-Lee, who is named as the father of the internet and the web, the World Wide Web, not the internet, right? The World Wide Web. And that means in the year 2019, it was kind of a celebration, okay, for the 20 years of the web and so on. And that was also the very first time we do have the internet, the World Web, the 1990. As of now, how many years? 20. We are 2023. So it's already 33 years. Wow. Older than many of you. Okay. Younger than myself, I'm sure. I'm sorry, but anyway. All right. Okay, so this is kind of evolution. Okay. We start from PC, personal computer era, right? 1980, 1990. We evolved to Web 1.0, okay, kind of connecting information, evolving to Web 2.0, connecting the people where there are kind of, there were more of the websites and so on. And people started to use web, more of the users growing a lot in the Web 0.0 time, Web 3.0 and 4.0 and so on. So I think I'm just go quickly, okay? This is just kind of learning from the past and seeing what happened. The very first generation, that means how we use, how user get information from the very first time, okay? This is kind of very text processing. Maybe this you never see. You can see from kind of emulation and so on, but not for real. So we go to open terminal, connect to remote system, so on, connect to the telnet, FTP, and many of these things through just the text command. And the problem that time, of course, it was very, it was meant for very few people. I mean, those who could access technology were just very small number of people, right? Just the experts. And actually using internet, using computer require a lot of expert knowledge, and was very expensive that time. Those who can earn the money, who could actually invest to have the computer, who could actually access computing resource, were small, and also it was expensive. Okay, information retrieval was also expensive and so on. Then we do have, I'm not sure, I don't think you were there in this generation, but yes, this is correct. This was my very first internet browser, Netscape. I still remember this when I made this. Yes, this was really my very first internet browsing experience, okay, using Netscape and so on. And yes, anyway, information access in the second generation of the web did not require much of the expert knowledge. So that means it could attract more of the internet users and internet those who produce content on the internet were more, because at the very beginning time, it was very small number of people who could have the knowledge, have the resource to contribute to the internet. But later on, of course, it kind of expanded. There could be more users, there could be more of the contents available and so on as well. And that means it was based on what you are very familiar with. That is, we make use of HTTP, HTML, websites, and so on. You could create web pages, okay? You could use web browser. You load the document, you click on one link and browse to another link, and so on. So information retrieval was there already through search engine. You know, before Google, what was that? No idea when you were born or when you were started to use internet. Was it Google, the first search engine you used? What was it? The search engine, not the browser, but the search engine. What did you use apart from Google or before Google? Okay, you were about to say something else. Yahoo. Someone said Yahoo. Yes, Yahoo was before. Anyone had any chance to use something else? AOL, American Online. That was kind of service. I'm not sure whether they had kind of search engine or not, but there was Yahoo before Google. There was Lycos, a few other things, but after Google time, nothing could beat for that time yet. Okay, until now, right? But now we do have Bing and a few others. Anyway, but let's see. Someone say something. Wikipedia. Oh, okay. Wikipedia is more on the cloud sourcing and knowledge, right? Collective knowledge, but not a search engine yet. Okay. Anyway, let's move on. Then in the next generation of the web, we could think of the web as the web of data. It's kind of more for the upgrading of web to consider data inside the web for machine accessible and machine processable data. In the second generation, and this is the vision that Tim Berners-Lee has made and has coined the very first time for the term semantic web. Even now, the word semantic web may not be so popular, but there was some other term. It was evolving as well, but basic idea was kind of the same. That is, we want the web not to be for human readable document. In Web 2.0, the web basically focused on being or serving human. You browse, you read, you access the content. Search engine is there, was there for you to locate where is it for you to find something, right? That is on the web. But one search engine tells you, here it is. You go and read and consume the data on the web by yourself. That is, we call it web for human. But once if we could make a web to be for machine, meaning that machine could, as of now, machine could already, of course, you know, the content along in very many websites, machine could index, could collect and do many other processes and then do the processing for you. That is what we aim for, making the third generation web to be web of data. And making all the content linked together, connected with each other, and then able for machines to process them for the user in order to allow more of the intelligent services, applications, and so on. But we will talk about this, okay? This kind of figure or diagram, we will see more and more. It is called link data, in which each small node would represent certain data that may be linked or connect with other data. And all of this data is available on the web, not by means of one HTML document, but just single data piece, data item. Okay. The architecture of the web, as we already aware of, okay, it is based on three important technologies. HTTP for communication protocol. This is the must and nothing changed from that time till now. URL for addressing, referencing mechanism, you need URL. Still, we need that. HTML in terms of the content presentation. Okay, these are three key technologies underlying the web success. I'm not going to talk about this in more in very detail, okay, but I assume you already know a lot about this. I will talk about one small thing here. Actually, for URL, it's mainly for addressing of anything on the web. Everything that exists on the web has URL, like http www.ait.ac.th, http www.cnn.com, bbc.com, whatever, right? This is the address that wherever you want to go and browse, you use URL. Another concept we will need a lot in our course is called URI. Uniform Resource Identifier is more for the ID. It doesn't mean that it is an address or location. For URL, it is Uniform Resource Locator, more for the location and address. URI is more for the ID. So anything can have an ID, but does not need to have address. So ID and address is different thing. You can have an ID. I can ask for your ID. You can have ID, right? Everyone. But you may not have an address, or you may have different address that is not your ID. Okay, so URL and URI are should be two different things. And in the semantic web and in other technology, we will discuss more. We will rely more on the URI as Uniform Resource Identifier to identify a resource. For example, to identify AIT, we use this ID or URI. But a web address of AIT is something else, right? Could be the same or not, it's okay. But something may need an ID, but may not have an address on the web. That is fine as well. But we will talk about that later on in more detail, don't worry. And any physical resource can have URI. So that means I, as a physical resource, physical object, I can have URI. I may not have URL. Suppose I don't register for any web address. I don't have anything on the internet world that represents a URL for me. but I can have URI to identify myself. Okay, such as it could identify everyone in Thailand by using thaicitizen.com/something. That could be my URI, sorry. So that is the unique ID for every person in Thailand. Okay, anyway, I browse quickly. Okay, web success was due to simple architecture. As I already mentioned, 3 underlying architectures behind the web are HTTP, URL, and HTML. These are 3 underlying architectures that make the web successful due to its simplicity. The network, all data are linked. Mostly the documents are linked, make the network effect. Okay, once data grow, values grow, services, users, and so on. It's extensible, tolerant, that's very good. Users can make mistake on the web. You can write very poor HTML and it's still browsable, right? Have you tried writing poor HTML? You open the tag, forget to close, it's still browsable. You don't get syntax error. Once you do HTML in the same way as writing program, then maybe HTML will not be successful because most of the time user may make syntax error, right? And then it's not browsable, but no, it will be very tolerated. It tries to tolerate all the syntax, ill form syntax and so on. Okay, anyway, it's universal, single standard. It's very standard. It's free, it's simple, powerful, and based on, as I already mentioned, open standards. So that is the success factors behind the web. Okay, and already I talked about standardization and open standard. Okay, but anyway, the key things that was Web 2.0. Web is based on markup language, namely HTML, to describe the presentation, how it looks like, how one HTML document links to another HTML document, and so on. But basically, the main users of HTML and Web 2.0 are human. It's human-centric, made for human mostly. So, what if we want to go beyond Web 2.0 and try to make the web more meaningful, not only for humans, but for machines and applications, such that, again, later on, the processing will be for human anyway, but less task for the human. And that is the evolution that goes towards what is called semantic web. First, I want to give definition. Okay, please read. This is the meaning or definition of the word semantics, taken from Oxford Dictionary. So, done with the reading, right? So what does it mean by semantics? Basically, we are talking about meaning. Okay, so what does it mean by the semantic web? So we want to refer to the meaning. So that means with HTML, the web that is presented by the form of HTML basically focuses on presentation, content, the way to present it. But the semantic web would like to focus on the meaning that is inside the content that the web represents. So this is a book, for example. I took one book. This book has this cover page. When we want to describe about this textbook, when we want to say about the semantics, it means semantics mean the meaning, right? But actually also, when we want to say that, what is the semantics? What are these book semantics? It means, please give me some description or describe about it. So it's more on the description of the thing. That is the semantics. So what is the semantic of this? What would you describe? If you see this book and I want you to help me describe this book, what kind of criteria or ways you would describe it? For example, you may describe it by title. What is the title of the book? Foundations of Semantic Web Technologies. Okay, very good. What else we may describe it? Authors. These are the authors, I suppose. Okay, what else you may want to describe it? Maybe publisher. And something you may not see from here, but you may want to describe, maybe publishing date, publishing year, the price, the language, how many pages, the cataloging data or the keywords of the book, or the abstract, and so on. Anyway, so these are the semantics of this thing. In this example, the text. Okay, so anyway, so that is the definition of the word semantic. When it comes to, how can I hide this? Okay, when it comes to the definition of semantic web, okay, I want you to read this vision firstly given by Tim Berners-Lee about this. Okay. Again, it was given in 1999 when actually that time most of the technology were still around Web 2.0. Okay. But when someone gave a vision, don't worry if you could not 100% understand what did it mean. What does it mean? It was a vision, right? It has to be something not very clear, but it's about what he aims for the future of the web. The key message is that data on the web, when we talk about data, I will have a few other slides later on. When we when we say the word web of data, what does it mean? We will talk about that. But let's read another definition, which is easy to understand in this way. Okay. Semantic web is an extension of the current web in which information is given well-defined meaning, enabling computers and people to work in cooperation. Basically means the machines should assist humans by taking the data for making some intelligent application or smart application and so on. I think nowadays we have seen many of these examples. Yes. 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 Well, not really new definition, but the new technology that make the definition or the vision possible or better. But still, it's the same thing. Yes. But I think we have not achieved the level in which we want to achieve yet. That means we can still make more advancement and improve the technology even more. But the goal is still there and achieved, but maybe closer and closer day by day. I think from this example, we could see that information in the website, okay, web pages, website, and across the web are kind of scattered, maybe not well integrated, and of course, it's about everything here and there. So mostly tasks that humans want to do based on the data available on the web is not by just one single website or web page. I mean, when you search a web, you may want information from here combined with there and combined with a few other data. So we may want to, usually humans may want to combine and integrate data from multiple websites seamlessly. Okay, such as, for example, if we all want to go for a trip together, let's go to Japan, okay, Tokyo, let's say. What we have to do? We have to search for airlines, flights, hotel, train station, transit here and there to go there, and maybe we need to also plan about the budget and so on. If we fly this day, the hotel pricing is like this. If we fly different day, hotel pricing and flight ticket may be also different, and so on and so on. You may need to combine and make multiple plan that is possible, right? And nowadays, of course, we could see a few services that did already do this for us, such as combining this airline with that airline and then suggest you that which one seems to be cheapest. Again, you may need to integrate wider than that, right? Not only within or among different airlines, but then I fly with this airline, which seems to be cheapest. I stay with this hotel. I book this taxi. I buy this train. I go to Tokyo Disneyland on this date and so on. Maybe pricing of different things are also different. Number of people who go there also different. All these kind of integrations allow human to do things manually, or for you to write some application data from different websites, but still it's not up to the level that you can automate everything easily. Okay. Even with the current technology, of course, you can do that, but still on a very hard code basis as of now. You have to be call the API of this hotel or airline, call API of this transportation, call the API of this travel tourist attraction venue or something. But anyway, it is possible as of now, better than the past, but still difficult. Not everything is fully automated and easy. And the reason is that most of the websites, the data that is available as of now is still operating using just HTML as the base information, right? Base technology. Even they use, of course, CMS, they use a lot of database, back data, and so on. But at the end, the presentation form of the website is still in HTML. Maybe they can, we can produce API interface. They can return JSON. They can allow data exchange in this and that format. But it's not in a way that can fully allow data integration easily. So this is what you are familiar with in terms of HTML, right? Still, HTML is coded in the way for presentation of the content in the form for human to read, for nicely view, and so on. So I think many of you already learned, let's say, for example, NLU, NLP, and so on. Is the way that if we want to enable machine processing of data, so we make machines smart, understand our human language, like NLP techniques, ChatGPT, large language model, many more, right? They try to understand human language using those algorithms and techniques and so on. And that is the smarter machines approach. Another approach, but of course, there could be a hybrid approach as well. But anyway, let's talk about, not this hybrid. Let's talk about this smarter data. That means make data in the form easier, formal, having clear semantics, explicit semantics with the data itself. So that machines here means computer applications, programs, can find, can access, can process data easily without any other algorithm to learn from the data. Meaning, expressing data and its meaning in certain standard format that machine can readily understand. If data is written in this format, it's not in the form that machines already understand the meaning, unless you go through NLP techniques, data mining, text mining techniques in order to grab, find pattern, find knowledge, find things inside from data. But if for smarter data technique, meaning that we express data in a form readily understood by machine. And this is, what does it mean by the semantic web approach? Making the web having meaningful web through incorporate data semantics into itself. But as I said, this is one way, smarter machine. This smarter data is another approach. Two different approaches. It's also possible to have a hybrid approach as well. combining both. Okay. This is what we already discussed. But then the interpretation of this is that, to make the meaning of data, that means the semantics, explicit, okay, to express the meaning of what you want in an explicit way with formal mechanism and standardized knowledge representation techniques. And that is one of what we will learn. I mean, one techniques we will learn is actually all of them. The technology we will learn, first RDF and then ontology. They are the approach underlying semantic web. So this is technology stack for semantic web. It looks a little bit 3D, okay, but actually I will have a more 2D version. But anyway, let's look at, yes, okay. Basically, this is the technical part. Okay, in terms of what technology underlying the semantic web, from bottom to the top. Bottom will be very more physical level. The top will be more on the application level. So the infrastructure or underlying infrastructure will be on the URI, HTTP, Unicode authentication. Okay. Up there could be a layer of some syntax, such as XML turtle, RDF, and so on, RDFA. And then RDF, and then OWL, RDFS, scores. And okay, I think these are what we will learn more or less. Where is Sparkle? Sparkle here. Okay. So what we learn, of course, basically, I'm not going too deep, right, to tell you about what is HTTP protocol and so on, but I think these are fundamental. We learn a little bit about the syntactic layer, how we represent each of the expression in the syntactic level of XML and turtle. This is the syntax to represent semantic web. The RDF and OWL, this is more on the knowledge. Sorry, model. Okay. Sparkle, this is on the query. Okay, it's here actually, it's on the query side. Okay, so this will be the technology we will learn. I think from this angle. Okay, that's nothing, I already explained, yes. Okay. So in summary, okay, this slide gives some summary that from the vision of semantic web, it focuses actually, for a simple term, it is just the web of data. But this data should have been presented in a way that has explicit meaning, formal representation, using some kind of standard technique for presenting the data, representing the data. so that semantics of meaning can be understood, can be presented, can be can be processed by the machine. Okay. Today will still be very introductory level. It's still very broad and shallow. Once we learn into the syntax level and some of the modeling concept and so on, I think it will become clearer. Otherwise, it's kind of, oh, the goal of semantic web is to do this and to do that, but still how to do it, you still don't see what does it mean by all these terms, ontology, RDF, and so on and so forth. Okay. So let's compare a little bit. Okay. This is original web concept, web of documents. Documents in this sense, this is one HTML file. Inside HTML file, right? You can have hyperlinks. You can link one sentence phrase to another HTML document, right? So it is considered as web of documents. While in the semantic web, it wants to model things, talk about things in the concept of web of data, more or less talking about the pieces of data inside the document, such that we can link each document, each data with another data directly, even they are on the website, on the internet. This node in the, let me go to, I think better I skip a few things. Okay, actually, what we could do is inside different web page, it should allow that in some web document, some document may model this kind of information. Some other document may model this kind of document, but still they can be linked to each other through the concept of what we call linked data. So actually there are quite a number of terms that people use and change and put another new term, but they refer to the same thing. Okay. So when we talk about web of data, actually it means link data. And later on, we will have another new term nowadays, that is knowledge graph. Okay. I'm sorry that we do have these so many terminologies, because when things evolve, people try to make new terminology to make it maybe sexier, easier, or I want to define my terms, not to follow and reuse the term other people has defined. Okay. Anyway, the concept of linked data is that we talk about pieces of data inside the web, in the web, instead of just the document. So it could be that actually somewhere in the internet, in the web, there could be a person, Jane Doe, having information saying that this is her email, this is her telephone number, and there is another somewhere else on the web saying that there's a meeting. We call it a cool meeting, such that it has this homepage, such that this cool meeting has this geolocation held in this place, and this place has the longitude, latitude, and postal address, postal code, like this. And it could be as well that this person, Jane, and the meeting are now related in the way that the person attend that meeting and so on. So even on the web, usually if we write information on the website in a normal way, common traditional way, we will just say that today we organize this meeting at Cambridge, Massachusetts, USA, and it's gonna be held, shared by Miss Jane Doe. Her email address is this and that, right? This is normal way. But actually, if we find a way to make the data represented in a form of machine processable mechanism or method, then this kind of data can be processed easily, such that you can query, okay, find me all the meetings held in Massachusetts. Find me the attendance list of that meeting to be held on this date and so on. So once the data is well formally represented, it can be processed, query, combine, integrated, or do in many ways. And that is the concept of linked data. Data can be across the web, but data can be linked even they are on different parts of the web. And that is, I should skip this because it will be there in some other slides anyway. Okay, I should go back a little more. Some of the slides I skipped, okay, actually they are kind of comparing the web of documents in the past and then the evolving web of the semantic web of data. So if we compare a little bit, okay, usually if we talk about web of documents that we already compare here, each single resource is a file, HTML file. And the web itself can be considered as a global resource, right? But it's a global space of file system. Just HTML file in this website, that website, and so on, different locations, but still they are on the web. Primary objects, they are documents. And when we link them, it's hyperlink from one document to another, one document to another. They are linked. There are links among documents. Semantics of the website, of the HTML file alone and of the link is very low. Semantics mean the meaning, right? There's no meaning. It's just say that there's HTTP reference from this website to that, from this web page to that web page, to this, from this file to that file. Okay. And the content of the document is mainly for human consumption, to read, to understand, to consume the data. But if we, okay, the challenges or the problem would be that data disconnection, it makes the data integration difficult. Once data are from this document and not in the same document and linked to other documents, integration of data, combining data that are related could be difficult. Okay. Querying across data sources are also difficult as well. If you want to retrieve data from the past, it's very difficult. But then if we move the web to the web of data such that actually everything that is stored on the web is like global database. I think every one of us learned database. right? You can think of database in whatever technology, relational, document, graph, and so on. If they are well defined in those technology, right? Data is there, but it's just decentralized. This data is in this server, that data in that server, and so on. But there are some structure, there are some relationship, there are some connection among the data. They are connected with each other. Then processing those data, even they're decentralized, it still be possible. It's like the concept of the linked data and web of data. That is, data can be anywhere on the web, but there must be meaningful link, meaningful mechanism to define the meaning and understand the data, their relationship, their connection. Then integration, query, processing would become easy and possible. And that is the concept of a web of data. So it wants to transform web of document into web of data, such that instead of having a global file system, we are having global database. Primary objects are not the document anymore, but could be just the data item. Things here means anything. So things are just data items. Okay. Links can also be anything. And the meaning of the links can be defined as well. Okay. Structure will be higher because it's kind of graph structure. Semantic will become more explicit. And machines can readily comprehend the data. And once machine can comprehend, they can serve humans. Okay, I will skip this part, but we will come back later on. Okay, but this is the way that we allow meaning of data to be modeled in the semantic web. But let's look at the goal a little bit. Okay, we have heard of several keywords. One important keyword here is linked data. Okay. When we talk about linked data, I want the pictures that come into your mind. Okay. You can search in Google. If you search with the keyword linked data and go to image, what will you get? Okay, let's try. I want to see too. Okay, let's search linked data. Not LinkedIn. Okay. All right. These are the search results of linked data. Mostly you got this kind of pictures as result. Okay. So what does it mean? Quickly, if we try to understand what does it represent from here, okay, and what does it tell us from the name? Linked data, of course, is data that has been linking with each other, right? And actually web of data, web means web, the spider web, web of data, linked data. I think, as I said, they try to just give you confusing names, but they are the same thing, same thing. Okay. So you could see that actually what are common here? There are kind of graph structure. where we have nodes. Node link. Oops, I should not click. Oops, what do clustering? Albin, sorry, you answer or type in clustering to answer something.
Yes, Professor.
What was the question that I asked and you respond with clustering?
What did the image look like?
Okay, I see. Okay, it looks like clustering to you. All right. Okay, it's kind of more or less graph structure. Okay, such that you have node, you have link, and then another node, right? And this can be kind of very dense, okay, very dense, and also more or less it has direction, so it is directed graph, right? But very dense directed graph as well. And mostly many of these graphs may have some kind of different sizing in terms of the nodes. I mean, some node is bigger, some node is smaller. Okay, it depends on whether it has some meaning inside the size or not. But anyway, back to my, okay, maybe I don't need to go back to my slide, but I can explain some from here too. I think we all learn graph structure, right? Node, link, node. With directed graph, it means that we can link one node with a direction or arrow or link with another node. And each node carry some information or meaning or data, represent some data, such as here. If you look at this one, okay, I come here. The first node is Tim. The second node is London. And there is a link, birthplace. Actually, with the graph structure, you can easily understand the meaning, right? And the same for a machine as well. We understand that there is an object. There's something called Tim. There's another thing called London. And there are some relationships between, there is a relationship between these two things called Tim and called London, such that Tim may have a birthplace, which is London, right? But since you're a human, you know that, oh, Tim must be a person. London must be a place. But actually, if you think that yourself is a machine, oh, this is just something called Tim, which is maybe something really you don't know, right? It is like something called X has a relationship Y to something called Z. That's the same thing for machine, okay? But then anyway, there could be another way that you can, a machine can understand the meaning more as well. For example, something that is called Tim would have another explanation or another link. Okay, I should go back to my slide then. Oops. Yes, before we have this Tim, and we say that it has birthplace, London. This is an example of linked data for sure. But this is just one simple linked data, right? And very small. Actually, each node may have a lot of connection to some other nodes too. For example, it could have been defined that Tim is the person. Oh, but okay, again, as a machine, person means just some symbolic, right? Something could be A, B, C, X, Y, Z, and so on. So what is a person? A person could be subclass of, if we learn biology, maybe, I don't know, I'm not very good at biology, but let's say mammal, if it's too high. A mammal is a subclass of something else. Animal. Okay, sorry if my biology is so poor, but anyway, there will be a lot. London is what? Is in what? England. London is a capital city of England too. London has population. I don't know, sorry, but I will guess 15 million. Okay. London has size. I mean, how many square kilometers? I don't know. And so on and so forth. With this way, actually, this is the way that we call linked data. This is just a simple form of linked data. In the real form, all of these node and link, it should be unique. It should be represented by some identifier, URI, or something that can be unique, that can convey, represent the meaning, and so on. And many more that we will learn. And actually, each piece of information that we see here could be described in one website. Some place here describe this, some other place describe it. And then all of them are interconnected. It's not like one person kind of try to explain everything in this one big graph. It's impossible, right? Maybe I myself, I am an FC of Tim. I describe him. You work for the London city governor, or I don't know what is it, the way to, but anyway, this is described by the government office of London. Something else, maybe if Tim, where does he sit? Where does he, suppose, we don't know who is Tim, right? He study at AIT. Someone else explain and describe the meaning of AIT. Of course, AIT office will do that, okay? And all this explanation, I mean, semantic description of AIT is provided by the others. All of this information will be able to link with each other through the, of course, the web mechanism. We can gather this small information or connect further to get bigger information and so on. In the same way as you browse and connect through hyperlinks, right? You start from one website, AIT website, you hop from AIT to the other, and the other. That's possible. This is again the same. Every link here is browsable to connect, and then you can get more and more of the data and so on too. Okay, so that is kind of, what does it mean by linked data? I believe I should stop here and let you have some break first, and then we continue. Okay, let me continue. So this is just to summarize that when we talk about the word linked data in the semantic web, the goal is that data on the web should be published in a way concerning linked data approach. It encourages reuse, reduce redundancy, maximize interconnectedness, and enable network effects. How and what does it mean? Enable reuse means that whenever someone already explained about something, such as explain about London, you don't need to re-explain in the same way, right? You add only additional information. It's the same that you make reference to existing description. If information about Tim has already been explained and you want to talk about Tim, you just link to that explanation or description. If information about AAT has already been explained, you just link to it. So that is enabling reuse. It's similar to web in the sense that actually you should not repeat the same thing, but normally we make it easy, right? We want to re-emphasize something in our website rather than point to the link or link to another website or something, right? But we just keep it in our website for explaining the same thing. But in that case, actually, if we encourage reuse, we reduce redundancy because information update in the database concept, actually, we should not have a lot of redundancy because it increases the problem of consistency, right? When many people explain about the same thing, there will be consistency issue for sure. Okay. And maximize interconnectedness in the way that you should connect this description, this web link data with another link data and so on and so on. And in that case, it will enable network effect. That means increasing and expanding the graph network. Okay. What is it here? This is the size of linked open data. When it is linked, LOD means linked open data. Because linked data is a concept that we already learned, right? It's a way to explain, describe web of data and so on, but maybe it's not open data. Open data means data that is available for you to access, to connect, and to use, right? But linked data may be for internal data of the organization, can be used for internal purpose, private data, and so on. But when it becomes web of data on the open web, linked open data will become very important because it's the data that is openly available. And this picture that I will show some kind of evolution. In 2007, the size of linked open data is just this, okay, about 500 million. When we say triples, it means this. This is one triple. Node, link, node. It's called one triple. When you have node, link, node 2 times like this is counted 2. So 500 million triples, you just need to count in this way, okay? So that is considered small. But then in 2009, people become aware and then make available of the linked open data more and more and more and more. And actually, if you search for the word linked data in Google, right, I think you have seen graph that looks in this way, like this. And you could see how dense it is, how crowded it is, and so on, and how big it would be. in terms of triple counts, I think nobody is interested in counting anymore. But as of 2011, the count is about 31 billion RDF triples available for link data, link open data on the web. And these are examples of available link data, link open data. What are they? One of the central, actually we call the nucleus of link open data is DBpedia, okay? Because it is kind of very big knowledge source, okay? So it's still considered as the nucleus of link open data that everyone links to it. I think you are well aware of Wikipedia, right? Every one of us makes use and benefits from the existence of Wikipedia. But still, Wikipedia is for human, basically, mainly for human. But anyway, there are also some parts of Wikipedia that has very well structured. And there was a community effort that convert Wikipedia into link data format. And it is called DBpedia. And still the effort is present. But of course, there is available data set of DBpedia in the link data format that you can download and use. And there is also some commercial version of DBpedia that you may need to pay and use as well. But DBpedia make use of the link data technology, basically RDF, basically what we will learn in this course. Okay. And this is an example of the structure data part of Wikipedia that DBpedia mainly extracts the info box part that has a very well structured data in which it describes key information of everything on Wikipedia, right? Such as if we talk about a city, Innsbruck, there is a key info box here, say that the name of the thing is Innsbruck. There's also even the image. There's also the image map. There's the state. There's the country. There's population size, the area, and everything. So this becomes available in DBpedia as part of DBpedia. So actually, in summary, everything that is available on Wikipedia is also available in DBpedia, but for the structure part. Some of the narration in human natural language part, natural language description may not be available, but structure information is completely available. And from several years back, this is some statistics, okay, that it's DBpedia data set in the linked data format is about this size, 1 billion triples, 111 languages, these many resources description that it catalogs, it has in the collection and so on and so forth. Okay, so the very next thing, so DBpedia is one of the very important thing as part of the linked data, as I already mentioned. Another thing, as I already said, there are a series of terms and things that we can see in terms of the evolution, right? Google Knowledge Graph is another thing that is based on this concept of semantic web, resource description framework, linked data concept, and so on. So Google Knowledge Graph, what does it mean? I think you're aware. Maybe I can get from you first. What is your understanding of Google Knowledge Graph? What is it? Any idea? Or have you heard of it? Or what do you know about it? Nothing? Have you heard of this before? Anyone has heard of the term knowledge graph or Google knowledge graph? No? So this is the first time? Okay. In the online, anyone heard of this Google knowledge graph before? Are you still there?
Yes, I'm still here, but I've never heard.
Oh, okay. That is Tan, right? You said?
Yes.
Okay. You never heard of it before?
Yeah.
Okay. All right. No problem. So actually, every one of us, we know about Google very well, right? We are the very good customer loyal, have very high loyalty to Google. We use almost every of the Google product if available for free, right? Okay. So Google basic service. The center of Google service is search engine, right? Still now, right? We consider Google very important because the very first thing is searching ability. For finding everything available on the web, you use Google. But with searching, of course, without knowing any context, but of course, Google tries to be very smart, right? Google developed itself to have smarter solution every now and then in order to serve the users the best. If actually, when we talk about search engine, it's actually a problem in the world, in the computer science problem terminology, we call information retrieval. You have a lot of information available. Google catalogs, Google retrieve, Google crawls a lot of web data. And users want to fill in a search term and Google returns the result. That is information retrieval. Problems, of course, you fill in, you search by using keyword. Mostly you use keyword search, right? Fill in the box of Google, the search term you want to look for. Basically, by the search term is the natural language that you fill in Thai, in English, in your own local language, whatever. There is for sure problems of ambiguity, polysemy, synonyms, and many more of the information retrieval problems. I think you can guess these I captured from Google, this picture. What did I type in as a search term? Jaguar, yes. It represents ambiguity because you don't know, Google don't know what jaguar did I mean. As an animal, as a car, or what? Luckily, only two types of things, right? Here that you could see. So this is an example of the problem. And actually, when we talk about searching, there are more than just keyword search. I mean, there are a lot of technologies, things, and development behind the searching. When we talk about the very starting point of the computer technology, the size of data, for sure, small, right? Nowadays, size of data is huge, big data for sure. In terms of productivity of the search technology, of course, before the technology was simple, search algorithm may be based on some easy algorithm. Nowadays, there are many more of the search algorithm to add a lot of advancement. Okay. Database. Searching in database definitely rely on exact match. Right? You want to search for select star from student where name equal Shutiporn. You get only Shutiporn. There is no synonym for Shutiporn. There is no ambiguity, concern, or anything. It's exact match for sure. Searching in files and folders, right? In computer system, in directories. Then there's more of the development for keyword searching, taking into account perhaps synonyms, polysemy, and many other things. Okay. There is more of the advancement. I'm not sure, have you heard of this? It has been popular term tag for some time, but now nobody use it anymore. Folksonomy. We have in lexical in the linguistic and language technology, there is kind of thesaurus, taxonomy. Oh, I'm not able to spell it. Then when there is kind of web 2.0 for the social web, we have the term folksonomies. Now we have a lot of tags, hashtags, cloud, tag cloud, and so on, more and more. There is also automatic semantic tagging, natural language searching. Now you may not type just the keyword, you type the whole sentence of what you want to get. That's also possible now, right? Even Google try to play itself as beyond search engine as of now, and so on. Intelligent, scale reasoning, and so on. Okay, this is kind of evolution of searching. As amount of data grows, keyword search is becoming less productive, but still it's the heart of everything as of now. In Google Knowledge Graph, actually this term, the word I use Google because they already registered this knowledge graph as a kind of trademark or something under Google. So I should always refer to Google Knowledge Graph, but actually the original idea actually is not purely invented by Google. As I said, it's based on linked data, semantic web concept, this and that. That was the real original, but Google has also made its own kind of search stuff and technology and call it knowledge graph. It's a knowledge base used by Google to enhance its search engine. As I said, Google doesn't want to be just very simple search engine, right? It wants to be very smart search engine. So instead of just returning the result to you by just simple search matching mechanism by page rank algorithm or whatever is too simple now, it's beyond that as of now. Okay, so it gather all information, the info box. Again, we refer to the word info boxes in Wikipedia. So info box is there, available longer than Google started to use as well. But of course, anyway, it's very common term now when we talk about info box. But if you search by Google, you will see the info box next to the search result. You'll see some search together. And it was added in 2012. Okay, maybe you have not recognized a lot of changes, but the info boxes that appear there is considered as kind of Google Knowledge panels to describe additional things. Okay, let's look at what does it mean. Suppose I search AIT, Asian Institute of Technology, before the original search version without knowledge graph and info box, you will see only this kind of thing. Mostly just the result, not this even, just a list of results, right? 10 top 10 results that Google think it is the top most relevant result. That is what you will get returned. But nowadays, of course, there will be sponsor, there will be ads, there will be this and that. Okay, that's for Google business model. But anyway, now if you search for Asian Institute of Technology, or you can search for something else, first you got the topmost results. You may get some other things that Google tries to guess what you are interested in. It's not just simple keyword search, but it guesses what should be the thing you like to click and search for. This is the info box. It will summarize. What does it mean by info box? It means what you search, instead of you click and browse and find it yourself for the search result, right? Whether it meets what you want or not. It tries to summarize key information for you in a way that you may not need to click anything. You just grab the thing from the info box. So this is the key thing that Google summarized about AIT. Asian Institute of Technology, short description, address, phone, people, notable alumni, and what else? Other people also search for something else. You try something else, you get different result as well. And how does this come? Google can return you this because underlying AIT, oops. Because when Google crawls and collects data about AIT, it doesn't do things similar to 20 years ago that just crawl and index keyword and homepage of the HTML page and data inside the page, right? It's more of the, oops. It tries to model the knowledge behind everything that it searches or it crawls. And using the concept of knowledge graph, it knows that, oh, there's Asian Institute of Technology. It has the web address, of course, because Google needs to return some result, right? It has to keep the web address for sure. It needs to keep maybe about, and that short description that you see, it needs to keep the address, I mean, physical address location. It needs to keep also the phone or contact and email and so on and so forth. And return all this into the info box format. It does the same for every other concept or thing. Such as if I search for a person, for example, Joe Biden, I will get the info box like this. This is from Google. If I search for a movie, entertainment, Star Wars, I get the info box like this, containing some short description, original work, short film created by, owned by, and so on. If I search for an organization such as EU, I got info box, including the area, the headquarter location, and so on. Every types of resource, we call in our terminology that we will learn, we call resource, but it could be anything or just thing. So any resource may have different ways to describe, and this is called the semantic, right? That is why we call, either Google call it knowledge graph, Tim Berners-Lee call it semantic web, and later on we call it linked data. It's all about the same thing. That is, we try to describe a resource, a thing, in the meaningful way. Okay, If you talk about a country, this is the thing you will get as an info box from Google. But how does it do in this way? Yes, this is the knowledge graph, as I mentioned. Person, this is the person, the place, the country, the city, and so on. They all are linked. They all have the description, which can link to one another. Okay. So behind Google Knowledge Graph is ontology as the knowledge source to model structured data and the relationships behind them. It's available in machine readable format that it can render. It can be rendered and present to human for human consumption. But underlying, it has to be in the form that Google, right? The machine, the application can understand, can process. And it's in the form of integrated and linked data, because like this, as you all see, even you talk about Barack Obama, it will be related to a country. It may be related to a city. It may be related to another person, and so on. They all are linked and can be integrated. Okay, but as I said, now Google is not just keyword search engine. It tries to be smart, tries to understand the context and the language, the query that you form as natural language query. So you can ask like birthday Joe Biden. It will try to, even you can give some misspelling, typo, it will correct you, right? But it will try to answer what you want. So it's not a search engine anymore. It turns itself to be also a question answering engine. It gives you question answering. Ask for birthday. Okay, this is the birthday. I gave you the answer. Even calculate the age for you. Even try to suggest you something else. If you're interested in Joe Biden, okay, how about Donald Trump? And I also suggest you the birthday of Donald Trump too. Not only the person, right, but the information you might want to compare and know about. Or Barack Obama, or the wife, Jill Biden. Okay. And again, the info box is still there. Okay. And everything here is possible because of the underlying technology inside Google, that it needs to connect all the related information together for suggestion. Otherwise, it cannot do this smart search for you, right? Okay. As I already mentioned, so behind Google already mentioned as part of the technological name that it names as knowledge graph. So you could see that the main thing is how to model the data and the knowledge. It will not be possible, right? If you could not properly model all those huge data Google collects properly. So knowledge model or knowledge organization is important technology. And that is what we will learn in this course. If we use, as I already mentioned, folksonomy, is kind of free text tags. So similar to tag cloud, similar to just hashtag that people in social media once frequently use nowadays, but we don't hear the word folksonomy anymore. We just use hashtags to refer to these and so on, right? But in the past, it was referred to as folksonomy. Okay, there could be predefined terms, okay, control list. There could be taxonomy, the way to make knowledge organization. There are also in this continuum, it means that it is a more of the structure and mechanism. The more advanced is to the right, the simplicity is to the left. Okay, so ontology adds more of the structure and reasoning. Knowledge graph try to add more because it embeds not only the ontology and knowledge graphs organization, but incorporate machine learning and other AI techniques as well. So this is more of the hybrid approach, using machine learning and NLP techniques combined with the ontology and knowledge representation techniques. Okay. I will not talk about ontology now. Okay, I think it's already too much for today, but just to give some idea, okay, because we heard the term ontology, it's kind of a branch in AI, for sure, okay. It has a reasoning, inferencing mechanism, and so on, but more on the knowledge representation side. Knowledge representation and reasoning is one technique. And very much different from natural language, in which natural language has a lot of ambiguity because it's for human, right? But ontology is very formal and precise. So we can use ontology as an explicit specification with taxonomy, means hierarchical of the concept, hierarchical structure of the concept. So we can order the concept taxonomy. Okay, this one is broader, narrower. This one is superclass, subclass. This one has these properties and attributes. This one has rules and constraints. These are well organized knowledge structure. That is what we call ontology. So you can define and model ontology for a particular knowledge area. Okay. And this is an example. There is several ways to represent ontology, either using a graphical notation like this, okay? When we talk about a domain such as pizza, okay? This can be an ontology, a small ontology of pizza, such that we have the concept pizza. Under pizza, there are two types in this example, veggie and mushroom. There could be margarita, there could be the topping as another class, and then they are related and so on, okay? And with ontology, there are a wide spread of possible applications that we will learn in this course. Okay, we'll learn some, not all. We may not be able to implement everything or try everything, but for sure, we will use ontology to try some applications. Okay, I think this is an example of same thing in Google that is backed or supported by the ontology mechanism for searching, such as it could allow with ontology in terms of search. We could perform information extraction. We could perform information retrieval in the sense of faceted search, synonym search, some recommendation and question answering support as well. Synonym search, you know what is this? Is Bangkok in Thai? Yes. How do you know? Because you read this or because you know? Yes. Krungthep is what we call in Thai for Bangkok. Thai people will not call our city Bangkok. Of course, we call it in English, but in Thai it's Krungthep. Okay. And this is a synonym search. Faceted search means you can search with a variety of criteria and so on. Okay. Even for the image, for the video, for the related information and so on. Okay. So I want to conclude now. Okay. With the semantic web, this is what we meant for the semantic web, the evolution towards the web of data, okay, in which all the data within the web could be linked, could be connected, okay, and this web of data could be on everything, not only digital data. It could be a person, a resource, and everything that we can model on the web. And actually, even now, we have semantic web, semantic of IoT, semantic web of everything, or something like that too. So once the data is connected and well defined, well formalized, it should bring another level of applications to human. That's the goal. That's the vision. Okay, support more of the automated work for human. And linked data is what we learn as kind of mechanism, approach, technique, methods, whatever. That is the driver behind the vision of the semantic web. Okay. And as I already mentioned, there could be a number of synonyms, even for the semantic web, linked data, knowledge graph, and those kind of things. They are in the same family of technologies anyway. Okay, so I think I should stop very soon.